And now I am going to show you how to work acceleration problems. These first two problems that deal with acceleration are horizontal. Remember that horizontal means along a flat surface. Okay, it is side to side. So we're going to start out with number 13. Again, first thing I want to show you guys is when I look at a problem, the first thing that I'm going to do is identify my numbers. I'm thinking all the time about what these numbers mean. Kilograms means mass. You have to memorize what these units stand for. Newtons means force. And here's one that we forget a lot. 0.1 meters per second squared. That's acceleration. Okay? Acceleration, again, I don't even have to read the problem to know about it, because I saw meters per second squared. But if I do read the problem, I know that we are dealing with accelerated motion. So we have a 198 kilogram video cart rolled down a hallway and accelerated 0.1 meters per second squared. I'm going to start my drawing there. Again, kilograms go inside the box because they are masses. So I've got a 198 kilogram video cart going down the hallway. I know how it's moving, even if I don't know the number. We know acceleration. Well, that doesn't go on my arrow though, but I can write down my acceleration is 0.10 meters per second squared. There is a force of 245 newtons applied to move the cart. Now I have some information about that arrow. This is the applied force. Applied force is always drawn to the right. 245. Some of you have asked, how do I know that that's going to the right? Look for your key words. Applied force. FA means applied force. And if you've memorized your picture, you know which direction that goes. So my applied force, 245 newtons to the right. The question is asking, what's the force of friction against the floor? Okay, now there are two equations that I know I will have to use in accelerated motion. I'm going to need F net equals ma. I also need F net equals my right plus my left. As an equation, FA plus FF. This is ultimately what I've asked for in the question. Okay, it says, what is the force of friction? So that's the last equation I'm going to use. I'll start here. F net equals mass times acceleration. Where's my mass? It's right here inside my box. F net equals 198 kilograms times my acceleration. Given here, written here. I don't have room for my units, but I'm going to remember that it's acceleration.
Could I have your attention, please?
So to work this problem out, I'm going to multiply 198 times 0.1, and I get 19.8. It is a force. It's measured in newtons. Now what I need to look at next, and a lot of us get stuck here, is to say, well, that's F net, but what is that good for? And some of you stop here. Remember the question asked for FF. There are two equations to use. We've just done part of it. We take that F net and plug it in. .8 newtons is equal to our arrows added together. I look back at my diagram. They gave me FA. I'm looking for FF. This is another area that's concerning me. When you see that sign, we have to do the opposite thing to get rid of 245. Too many of us are choosing the wrong operation. These are added. To get rid of something added, we subtract. So on this side, we end up with just FF. And on this side, $19.8 minus 245, I end up with negative 225.2. I don't have room right there to write my unit, and I want to make sure my units are there when I answer the question. Oops. So I'm going to rewrite negative 225.2 newtons. That's my force of friction. I ask myself, does it make sense? Absolutely. Friction is always opposite. Another way to look at this problem, I pushed 245 newtons. Friction pushed back. Actually, to be a little bit more accurate, friction pushes back quite a bit at 225.2. Applied friction. What that leaves is a blank. That blank is filled up by F net. That's what we get when we put them both together. So if I look at this picture, this makes sense. 245, negative, remember, is just a direction. So it's a pretty big negative force, a pretty big applied force, but applied is a little bigger, meaning that our net force comes out to be about 19.8. So here's your answer for that first one. Okay, I'm not going to talk as much through the second one, so make sure that you're pausing and working on your own. Okay, 24 kilogram bowling ball. Mass is always going to go in the middle. It is rolled down a bowling alley lane. Rolling goes flat, horizontal is the word. This is going to be an acceleration problem. So let me go back, highlight my numbers. Kilograms, meters per second squared, 94 newtons. Again, the key word that lets me know what I'm doing, I'm talking about accelerating. I'm also talking about friction, which means it is not in the air. Okay, 24 kilograms. I do have an acceleration of 1.1 meters per second squared. I have a force of sliding friction, and that force is 94. Okay, so my picture is taking shape. Again, I know with acceleration that I've got F net. F net equals ma, as well as F net equals arrow plus arrow, or FA plus FF. I have a mass and an acceleration. I'm going to plug that in. Again, I'm not done here. I take that F net and I move it right over here. I also need to look and ask, what do I know? in my picture, I know friction force. So, plug it in. The most common mistake I've been seeing with this problem is that we're forgetting that this is a negative number because friction goes opposite. This is positive, this is negative. Okay, make sure you remember that. So negative, so we add to get rid of it. 94 goes away. Means we have to add 94 on the other side. So I add these, and I get an applied force of 120.4 newtons. I rewrite it because I don't like how it looks. Done.